Hello, sixth graders. Welcome to our next math lesson. Today we're taking a look at lesson 107. It is entitled Area of Complex Shapes, and we are going to begin by looking at page 557. Now, a few lessons ago, way back in lesson 103, we talked about how to find the perimeter of complex shapes. If you remember, we had to make sure to add all of the sides together, and there was even a couple of sides that were missing, and you had to find those numbers first. Well, in this lesson, we will practice finding the area of those complex shapes, okay? So one way in which to find the area of those complex shapes is to take that shape and actually divide it into either two or sometimes even more parts. But I think in today's lesson, you'll be able to divide your shapes into two smaller shapes. Then what you're going to do is find the area of each one of those parts by themselves, and then we're going to add those numbers together to find the total area. So let's take a look at this figure here. It says find the area of this particular figure. Now, if I was trying to find the perimeter, I'd want to add 1, 2, 3, 4, 5, 6 sides. I already know 4 of them. I definitely need to find these two if I'm trying to find the perimeter. But since I'm trying to find the area, I might not need to find both of these answers. It really depends upon where I split my shape. Because if you take a look at the shape, this doesn't really look like a shape that we have studied before as far as formulas are concerned. So what we're going to do is we're going to split this particular shape into two smaller ones by drawing a line. So one thing that I might do is I might just take my pencil here and I'm just going to draw a line straight across here like this. And if I do that, now I have this smaller rectangle on top, and I have this bigger rectangle on the bottom. So now what I could do is try to find the area of this smaller rectangle, and then find the area of this bigger rectangle. Now, in case you forgot, the formula to find the area of a rectangle is you take whatever the length is, and we're going to multiply that by the width. Here's my fancy cursive writing here. Length times width. Okay. Now I want you to notice that this number 6 here, I'm actually not going to use this number 6 at all. And the reason why is because when I draw this line here, I'm splitting this 6 into two smaller parts. Okay. So in this particular problem right here, I know that I'm not going to need to use that 6 because I'm splitting that into two smaller sections. So then what I'm going to do is I'm going to try to find the area of this bigger rectangle first. And remember, I want to take whatever the length is. And if I take a look at this bigger rectangle, it looks to me as if this bigger rectangle has a length of 7. And I'm going to multiply that by how wide it is. Now, again, I don't want to multiply by 6 because 6 goes all the way to here. And I only want to go from here to here. And I know that if this is 4 centimeters, that means this also is 4 centimeters. So really, to find the area of this smaller rectangle, I'm going to go ahead and take 4 times 7. Excuse me, that would be the bigger rectangle. So I'm going to multiply 4 times 7, and that's going to give me 28. So right now I have 28 centimeters, and that's this big rectangle right here. Now I'm going to do the same thing with this smaller rectangle. Again, I want to take the length times the width. So I already know that my length is 3. The length is definitely 3. Now the width is not 6. Remember, 6 goes all the way down, which means I do want to find this particular A. So in this problem, I do want to know what A is. And so if you remember back from a previous lesson, since I want to know what A is, I'm going to take the two lines that are parallel to it. This 6 is parallel. This 4 is parallel. Let's subtract those two numbers together. So if I take 6 minus 4, that tells you that A should equal 2. So now I'm going to take 3 times 2 to find the area of this smaller rectangle. And 3 times 2 is 6. Now my last step is to take 28, and now I'm going to add 6 to that. And if I do my math right, 28 plus 6 gives me 34. And when I go to label that, I'm going to label that as centimeters squared because it's dealing with area. Okay, so with this figure right here, I did not have to find out A and B. I just needed to find A. B doesn't really matter. But then some might say, well, Mr. Johnson, okay, what happens if you were to draw a line not across? Let's say, for example, this is the exact same problem. What happens if I draw my line going up and down this time? Sorry for not having the straightest line there, but you kind of get what I'm talking about. What if I draw a line here? Now I have this rectangle, and now I have this rectangle, which means I'm going to have to find the area of this bigger rectangle first, which is length times width, which hopefully you can see that the bigger rectangle is 3 times 6. So 3 times 6, and I know 3 times 6 is 18. So the area of this rectangle right here is 18 centimeters. Now I have to find the area of this rectangle right here. And I'm not going to use 7 as the length because 7 goes all the way across. I don't want to go all the way across. I only want to go from here to here, which is the same as B. So I have to figure out what B is. So in this problem here, I don't need to know what A is because A doesn't help me, but B, I do need to find out what B is. And in order to figure out what B is, I want to take the lines that are parallel to it. So here's B. The lines that are parallel are this one, which is 7 centimeters, and this one here, which is 3 centimeters. So I'm going to subtract the 7 and the 3. 7 minus 3, excuse me, is going to be 4. So the B is 4. Okay. So now to find the area of this rectangle right here, I'm going to take 4 times 4. And 4 times 4 is 16. So the area of this rectangle right here is 18. The area of this rectangle right here is 16. Now I want to take and add these two numbers together. I'm going to take 18 plus 16. And when I add those together, I should still get the same answer, 34. And then I want to go ahead and label this centimeters squared, 34 centimeters squared. So notice it didn't matter where I split. If I go across or up and down, I still got 34. I still got the same answer either way. So the beauty part about this lesson, 6th graders, is you don't have to find both the missing numbers. Depending on where you split it, you're going to have to find one. So for this top one, I split across here. I needed to find A and not B. For down here, I split up and down, so I needed to find B and not A. Let's take a look at a couple of problems that are actually in your practice set. This is actually letter A. I thought it'd be a good idea to kind of go over this because there's a couple of points to this one. The directions tell us to draw 2 ways to divide this figure into rectangles. Okay? Then it also says to find the area of the figure each way. So you're going to have a couple points for drawing and a couple points for work. So here is the figure. Now, if you go to write this figure on your paper, it's not a bad idea to put those measurements in there so that way you don't forget where they're at. So when it says draw 2 ways to divide this figure into 2 rectangles, what you're going to do is you're going to draw this figure and then you're going to split it into 2 rectangles. Maybe you might say, the first one I'm going to split up and down. So this is one rectangle and this is another. But this is only one drawing. You're going to draw another one exactly like it. It's the exact same figure, except this time I'm going to draw a line going across this way. Again, I have a rectangle here and I have a rectangle here. Okay, so these are my 2 drawings. One has a line here and one of them has a line here. Now what I'm going to do is find the area of both of these rectangles and then add them together to figure out what my answer is. So again, I want to do length times width. I do not want to use 10 because 10 goes all the way across. So in this case, 10 should not be used. Okay, but I want to do 3 times, so I need to find this length right here. And in order for me to find this length right here, I want to take the 2 sides that are parallel. This side is parallel, which is 10. This side is parallel, which is 4. So now I'm going to take my 10 minus 4. That tells me that this missing side is 6 inches. Okay. Now I want to take 3 times 6. 3 times 6, this area right here is 18. Now I'm going to come over here to this rectangle here, and this one, it's okay for me to use 8 because I do want this up and down, and I want to know the 4 there. So I'm going to take 8 times 4. 8 times 4 would be 32 inches. So now I'm going to take my 32 inches and my 18. I'm going to add those 2 numbers together. And by doing that, I should get the answer of 50 square inches. I'm going to do the exact same thing down here. I'm going to find the area of this rectangle here. and I'm going to find the area of this rectangle here. Now this bigger one, I can use the 10, so 10's okay, and the 3. So I'm going to go 10 times 3. 10 times 3, so this bigger rectangle right now is 30. That'd be 30 inches. Now I want to find the area of this smaller rectangle, and I do not want to use 8 because 8 goes from here to here, and I only want to go from here to here. So 8 is not going to be used in this situation. But I do need to use the 8 to help me figure out this missing side here. So this side, I don't know what it is yet. I got to figure it out. So I got to take the two sides that are parallel to it and subtract them. So this right here, this is 8. We just said this was 8. And this one's 3. So I'm going to subtract those two numbers together, 8 and 3. That tells me that this missing side right here is 5 inches. Now I want to take the 5 times 4. So I'm going to multiply 5 times 4. 5 times 4 is 20. And now I want to add both these numbers together. 30 plus 20 is going to give me 50. So I got the same answer. So that's a good way to check to see if you did it right. Both ways you do it, even though you get two totally different numbers, when you add them together, you should still get the same answer, which is 50 square inches. Let's take a look at this next problem here. This one is letter B. And in B, it actually gives you a hint as to where to split this into two shapes. It says this trapezoid can be divided into a rectangle and a triangle. Very important triangle. In case you forgot, length times width, but then you got to divide that by 2. That's the formula to find the area of a triangle. If you forgot, make sure you divide that number by 2 first. So we're gonna divide this into a rectangle and a triangle. And I think the only place we can divide that would be right here, straight up and down, right here. Now you should be able to see the rectangle, and now you should see the triangle. So now I want to find the area of both of them. So again, I want to find the area of this rectangle. I'm not going to use 14 because 14 goes all the way across. I don't want that. So I'm not going to use 14 to help me figure out the area of this rectangle. I'm going to take 6 times 10. 6 times 10. So the rectangle right now is 60. That's 6 times 10. But now I got to find the area of this triangle. And I do need to find the length. So I do need to know what this shape is right here. And I also need to know the height. So I actually got to find both of these right now. Well, hopefully this one right here is pretty obvious what it is. Because if this is 6 centimeters, the opposite side of that rectangle would be the same number. So this area right here, this one, that one's going to be 6. Okay, so this is 6 centimeters. Now I got to figure out this side right here. And in order for me to figure out this side right here, I got to take the two sides that are parallel. One of them is this whole thing, which is 14. And I'm going to subtract the 10. If I take 14 minus 10, that means this missing number right here is 4. So what I'm going to do is I'm going to multiply 6, which is the height, and then 4, which is the width. We got the length and the width. So I'm going to do 6 times 4, which is 24. But a mistake that a lot of people do is they forget that with triangles, we still have to divide this by 2 because I only want half of it. So I'm going to take 24 divided by 2. So that's going to tell me that this little area right here is 12 centimeters. Okay, so hopefully you remember. Let me review what I just did here. If this is 6 centimeters, this also is 6 centimeters. That's where I got that 6 from. To figure out this number here, I'm going to take the whole 14, and I'm going to subtract 10 to find the missing number. 14 times 10 is 4. There's my 4. So I did 6 times 4, which is 24. And then since I'm finding triangles, I have to divide that number by 2. 24 divided by 2 is 12. And now for my last step, I'm going to take my 60, and I'm going to add 12 to that. So I take 60 plus 12, and my final answer should be 72, and I'm going to label it as centimeters squared because it's area. 72 centimeters squared is my answer. Okay. Now I know that I showed you how to do this stuff, but please mark this down on your sheet so I can see that you followed along with this video. Okay. All right. So that is how you find the area of complex figures. You will see on the screen right now that the assignment for this particular lesson is going to do pages 558 through 560. You're going to be responsible for doing letters A through 28. Now, if you watch this video, hopefully you get A and B right since all the answers are there. So if you need to go back and take a look at any of it, please feel free to do so. If you have any questions, don't hesitate to reach out to me, and I will gladly help you the best that I can. So I'm here for you. Good luck on the lesson for today, and we will see you with the next lesson.